In this example, we want to find out the differential gain. Just look at the circuit on the left-hand side. We have two ideal current sources where their output impedance is infinite. So we only consider output impedance of Q1 and Q2, which is RO1 and RO2. That's the reason you can convert it into a simpler model, which one has RO1 and RO2, like that one. So differential gain can be obtained as GM times RO. In the case, RO is the same as RO1 and RO2. So in the next examples, we can use half circuit techniques. As long as node P is connected to virtual ground, we can assume that one as AC ground. Then, assuming that R1 and R2 are the same, and RO1 and RO2 are the same, of course, RO3 and RO4 for Q3 and Q4 are the same, we can cut it half. Then on the left-hand side circuit can be considered as single-ended circuit, as like circuit on the right. Then the differential gain can be obtained as finding out single-ended gain, and its gain is minus GM times RO1 in parallel with RO3 in parallel with R1. This example, we assume that only voltage cannot be neglected. That means that we do not neglect RO1 for Q1 and RO2 for Q2. By assuming that node P is virtual ground, we can find out the half circuit. And also, assuming that R1 and R2 are the same value, the center can be a virtual ground or AC ground. So converting the circuit as like the circuit on the right, you can finding out the differential gain to be the same as a single-ended gain, which is minus GM1 times RO1 in parallel with RO3 in parallel with R1. In this example, we just neglect only effect by making VA is equal to infinite. Then we have the same RE between the emitter side of Q1 and emitter side of Q2. Then still we can assume that the node P is a virtual ground. Then simply the circuit on the left side is converting into the circuit on the right hand side. Then for differential gain is the same as the single-ended gain, as because this is common emitter amplifier, it is starting from the minus from output side to AC ground. You will see RC, and also the impedance of Q1, but we neglect output impedance by making this one equal to infinite. So you don't need to write it down RO1 blah blah blah. It will be neglected as an infinite value. Divide by, starting from the emitter side AC ground, you will see RE. Then you will see 1 over GM1. So that's your answer. And this example, we neglect only effect, which means that just neglect output impedance from this side. Then if you make a half circuit, you have to cut it into two components, which one is RE divided by 2 and also RE divided by 2, and the center will be connected to virtual ground. By converting this circuit into half circuit, then the gain is pretty much simple, such as RC divided by, from this side, RE divided by 2 plus 1 over GM1. In this slide, finding out the differential gain for the case that neglecting only effect. So the impedance here for Q1 and output impedance Q2 will be infinite, so you don't have to worry about that one. However, the RE, the center, if you divide this one with the two different components, that will be RE divided by 2, RE divided by 2. Of course, to make this one symmetrical, it is pretty much important to have two values to be the same. Then you can convert it into a single-ended amplifier, and the overall gain will be, the numerator will be output impedance from output to AC ground, and also denominator is given by 1 over 2 RE plus 1 over GM. So you got this value. Finding out the voltage gain for the case that we don't neglect channel length modulations, then you have to keep RO1 and RO2 and of course RO3 and RO4. So the gain will be given by, like as the right hand side figure, the voltage gain is minus denominator, the output impedance from this way and that way, is 1 over GM3 in parallel with RO1 in parallel with RO3 divided by the resistance from the AC ground to the inputs will be 1 over GM1. And finding out the voltage gain for the case that we neglect channel length modulations. So, of course, the impedance of current source will be infinite. And you don't neglect output impedance for this case, that case, and 4 different cases. Then by having single-ended output, you will have 1 over GM, of course the gain will be minus, and from the output to AC ground will be 1 over GM3 divided by, from the input, because this is virtual ground, to the inputs will be 1 over GM1. So finding out the voltage gain for neglecting channel length modulations. So simple. So you gotta make a virtual ground, which is RSS divided by 2. And here RSS divided by 2. And the center value will be AC ground. And for the output is the same. You have RTD divided by 2, RTD divided by 2. The center will be AC grounded. So you can convert differential amplifier as like the figure on the right. The voltage gain is simply minus from the output to AC ground is RTD divided by 2, but the output impedance here can be neglected because it's infinite, and denominator is starting from RSS divided by 2 plus 1 over GM1.